So students, welcome back. We are discussing most common power quality problems in the power system. In the last video lecture, we discussed about the harmonics. Today we will discuss about the voltage sag, also referred as the voltage dip. So what is the description? A decrease of the normal voltage level between 10 to 90% of the nominal RMS voltage at the power frequency for a duration of 0.5 cycle to the 1 minute. This is the voltage sag. So this is nothing but the decrease in the nominal voltage, means rated voltage between 10 to 90% and which persists for the 0.5 cycle and less than 1 minute is the voltage sag. What are the causes? The main cause is fault. The fault on the transmission or distribution network. See these are the causes. The fault on the transmission distribution network. Then faults on the consumer's installation. Connection of heavy load, startup of the large motors. A heavy motor during the starting draws heavy current from the supply, resulting into the ohmic losses, that is nothing but voltage drop. That results into the voltage sag or the dip. So faults like symmetrical, unsymmetrical, line to line, line to ground, double line to ground. So all these faults causes a decrease in voltage magnitude. That results into the voltage sag or a dip. So what are the consequences? What will be the result of this voltage sag on the power system? That will result into the malfunctioning of information technology equipment, namely microprocessor based control system like PLCs, PCs, and many more. That may lead to the process stoppage, loss of data, tripping of the contactors and electromechanical relays. There is a failure of the due to the under voltage relay will get operated, and even though there is a so that will result into the malfunctioning of the relays. So disconnections and loss of the efficiency in the electric rotating machines, like all the types of the motors, that will reflect into loss of the revenue. Let us see the next one, the voltage swell. What does it mean? A momentary increase of the voltage at the power frequency outside the normal tolerance with a duration of more than 1 cycle and typically less than a few seconds is referred as the voltage swell. Increased in the rated nominal voltage magnitude beyond the tolerance limit. It is nothing but the voltage swell. What are the causes? Start or stop of the heavy loads, badly dimensioned power sources, badly regulated transformers, mainly during the off-peak hours. So these are the certain causes of the voltage swell. What will be the consequences of this voltage swell? That will result into the data loss, flickering of the lightning and the screens, stoppage or damage of the sensitive equipment, electronic equipment, if the voltage values are too high. So flickering, stoppage of the electronic equipment, loss of the data. So these are the certain consequences arises due to the voltage swell problem. Let us see the next one, that is the voltage fluctuation in a series of most common power quality problems. So what is the voltage fluctuation? That is oscillations of the voltage value between minimum and maximum value. So voltage fluctuation is variation in the voltage unwanted. So oscillations of the voltage value, amplitude modulated by a signal with a frequency of 0 to 30 Hz. So it's also nothing but the one type of the harmonic problem. What are the causes? The arc furnace, frequent start and stop of the electrical motors like escalators, elevators, then oscillating loads. These are the causes for the voltage fluctuation. what will be the effect, what will be the consequences of this voltage fluctuation in a power system? The most common or the consequences are under voltages. The most perceptible consequences is the flickering of the lightning and screens, giving the impression of unsteadiness of the visual perceptions. So these are the most common consequences of the voltage fluctuation. See this normal period, fluctuation period, and then normal period. This region indicates us the problem of the voltage fluctuation. Decrease and increase in the voltage magnitude constantly. Oscillations. Let us see the voltage spike. What is voltage spike? It is nothing but very fast variation of the voltage value for durations from several microseconds to the few milliseconds. These variations may reach thousands of volts even in a low voltage. That is voltage spike, sudden increase in the voltage. Obviously, it is due to the lightning, switching of the lines or power factor correction capacitors and disconnection of the heavy loads that will cause the voltage spike. What are the consequences? Destruction of the component, particularly sensitive electronic equipment. It will lose the insulating material properties, errors in data processing, data loss, and electromagnetic interference. So these are the certain problems due to the voltage spike. See, this is the region indicating the voltage spike. Okay, see this one. Sudden increase in the voltage level due to the lightning. So that is the voltage spike. So thank you for your patient listening. In the next lecture, we shall discuss again the most common power quality problems in the detail. Thank you.